to, I guess, cement the concepts that we learned last week by trying to do some kind of project that uses all of the things that we've learned, including like lists, as well as for loops and if statements and creating model, etc. So before we get started, I'd like you guys to look at the Python Bootcamp folder on GitHub if you're following along. And on that GitHub, you'll have a folder named ML. And what I've included actually is not only some kind of like setup for PyCharm, but also the first 3 assignments of Intro to ML that we teach to students here at UTC. And so these homeworks that we give to students, they go all the way up to convolutional neural networks. So they may be helpful for learning if you're more interested in creating more complicated neural network through Keras instead of relying on predetermined models within sklearn. So in assignment 1, you have both an instructions.md file. This is the instructions that I give to students to fill out their projects. Then you also have a tutorial.md file that I'd like to go over, talking about the very basics of how to think of machine learning algorithms and how to sift your data in a means that makes sense for processing using these models. So before we get started, as you can see here, we're going to be using scikit-learn. And if I go ahead and go to scikit-learn, this is the website I showed you last time. And it's essentially a library for machine learning in Python. I'm going to stop sharing, and I'm going to go share a blank Anaconda PowerShell prompt again. And in order to install sklearn in any environment that you're using, it's as easy as doing pip install sklearn or scikit-learn. Both work. To make sure that you have it installed, you can go ahead and do pip show scikit-learn. And as you can see, my scikit-learn has a version. So if this works, that means you do have it installed. Going back into the web browser, let's go ahead and let's make a new Python 3 notebook, and let's just get started. So first, as many of you know, we actually need to import the library that we're going to be using today. So for what we're going to be using, which is a multi-layer perceptron classifier, it's as simple as typing in from sklearn, learn.neural network, import MLP classifier. So MLP classifier here is the actual class that contains the model that we want to use. Going into the tutorial, what we'll be doing today is actually classifying between 2 languages, English words and German words. And as you can see within the Python Bootcamp folder, or within the assignment 1 folder, we have a German.txt and an English.txt. If we looked at this text file, it just contained a ton of quote-unquote English words. Closing out here, what I'd like people to understand is that machine learning models, or any model really, works off of numbers and mathematics as basically the base or the engine that runs this model. And so having characters like these doesn't really make sense to put in some kind of mathematical function because these don't have numerical values. So in order to actually change these into numbers so that they can be processed through a machine learning algorithm or any algorithm, we have to change this to numerical representations of this word. One of the easiest ways to do that, right, if we were going off of the English alphabet, is to just change all of the letters to the number or the index they're in within the English alphabet. So say, for example, A would be number 1, would be represented by a number 1. Something like Y would be represented with number 25. There's an easier way to do this, and that's to get the ordinal value of a character in Python, and you can do that using ord. When you put a character into ord, it spits out the ASCII value of that character. So A has an ASCII value of 65, N has 78, Y has 89, so on and so forth. So when we represent anyone in numbers, we can change them to numbers and then store them all in a list that looks like this. So a string like this becomes a one-dimensional list filled with numbers. This is great because this is a very easy way to actually translate something like the word anyone or uproar or yellow, as you can see here, to their numerical representations. It is important to note that things such as images, which doesn't seem to have numbers, or at least for people who don't understand the image format, doesn't seem to have numbers because they have colors. But remember that these colors are represented through RGB values. And these RGB values range from 0 to 255 for many common image formats, not for raw formats. So it's important to note that even things like images, when they go into a neural network, they're being put in as a numerical representation of that data. And that's essentially what we're doing here. Now, what's also interesting to note is that not only our training data, which is the words that we're going to be putting into the neural network, have to be in numbers, but also the target data. The target data is essentially the labels. As we see up here, we have both English and German classes or languages. But these also need to be in numerical format. We don't want to be ordering this into some kind of number. We just want these classes to have a numerical representation. And so what's easiest to do is to just say that every time an English word pops up, I'll say that the output is 0. And anytime a German word pops up, I'll represent a German label as 1. And so whenever the algorithm takes in these numerical values, you would like the output to be 0, or you would like the function to equate to 0. And whenever you get these set of values, you'd like the output or the equation to equal 1. So let's get started with how to actually sift through our data files, or let's say our mostly like new line separated words, and change them into the numerical format that we need. And then see how we can put these data, both the training and the target data, into the model. So this tutorial is mostly going to be in pure Python, except for scikit-learn. There is no NumPy that's going to be taught here. I'm going to teach it in a way that is incredibly inefficient, but in a way that would make sense for people who are not familiar with programming. So first, let's take the files that we need. Our files, we can store them into a list, and we can say that in our folder, we had both an English.txt file and a German.txt file. So let's plug those strings in. Next, we actually want to go ahead and open these files. So let's go ahead and say for file in file, open file equals open. And we want to open the file. So the file represents the file name of the file we're trying to open. So the first argument of open is the file name. So we'll just say file. Now, the text file, we'd want to read it. So I'm going to put R. You don't always have to do this. But the reason why I want to do this is because I actually want to put one last parameter, and that's the encoding. The encoding of the text file is Latin 1, and that's not something that you necessarily need to be worried about. But the way that Windows and macOS reads these text files are actually different. And what you'll find is that on macOS, it reads this German text file very erroneously and causes the code to break. Therefore, we're explicitly stating the encoding of the file itself. This is usually not a problem, though. Then we can say that the words of the file are basically every line within this open file. So I'm just going to say file lines. File lines is equivalent to open file.readlines. And the reason why I'm saying file lines right now is I'm just noting to myself that these are the lines that are found within the open file that we have. If I go ahead and print file lines, oh, it says that the data rate exceeded. Let's say file lines up to okay. So we're printing the first two lines within file lines, and as you can see, in our English.txt we have A and AA for whatever reason. And in German file lines we have an empty string as well as this word that I'm not going to try and pronounce. What we're going to try and do now is we're going to try and read each and every line within these file lines, and we're going to only take 6-character words for now. And the reason why I'm doing that is because it really simplifies what we need to do for this, for the shape of the data. So I can say that if I'm opening the English text file, remember that what I want to have is the actual class target as 0. So I want to output 0 here. So I'm going to make a note. And I'm going to say if English is the file that's being read, I want my output to be 0. So now let's go ahead and just try and read all of the lines and see if they're 6 letters long. So first, I want to say that the amount of 6-letter words we have is equals to 0. And then I'll go ahead and go through every file line or every line within file lines. So for line in file lines. And now, because we know that every line is basically a word in the text file, I want to see how long it is. The biggest problem to that is that you can see here, there's this very odd character, which is \n. And if you don't know what \n is, it denotes to a text editor, etc., that it's a new line. So it actually means that A, and then there's an enter. If you press enter on your keyboard, this is basically that symbol. But here it doesn't represent enter because you can't really new line a list. So what we want to do, first of all, is just delete that. Easiest way to do that is say line.replace. You can also do strip, I believe. And you can do \n. We're going to replace \n with nothing, which means it effectively deletes the symbol. And then what I'm going to do is actually go ahead and lower the representation of this character. So we're going to say that the line is equals to line.lower. And the reason why is because when we look at A, for example, and I can do that really simply over here. if we print the ord of capital A, as well as the ord of smaller case a, they're different numerical values, which means that we don't necessarily want capital A and smaller case a, as we can see here, to be different values. We want them to be the same values. So what we're doing here with line.lower is that this effectively becomes, multi-line selection, effectively becomes this instead. So they're now both lowercase. So now we've removed this ugly character, which would end up essentially messing with our 6-letter words. Now we actually just want to go ahead and just count all of the 6-letter words, or all of the 6-letter words within our file. So we can say inside this if state, or inside this for loop, if the length of the line, and this is line now, is equals to 6, we could say ord line, so the numerical representation of this word, is equals to the empty list. And then what we'll be doing is just appending the numerical representation of each character to this ord line. So we can say for letter in our line, ord line dot append the ord, the letter. So essentially for every letter within our line, so for example, this word, for each and every letter, we're just going to append to this empty list the numerical representation of that character. Now, what's funny is that we have this ordered line, but we didn't even, we don't have a place to actually store this ordered line, this numerical representation of a word. We actually have to go ahead and make a training and target data set to actually store these values. So let's go ahead and do that. Training equals the empty list, and target is equals the empty list. Every time we go ahead and make this ordered line, what we want to do is actually append this created ord line to the training data set. So training.append the ord line. So the numerical representation is now being added to the training data set, which kind of looks something like this, right? So we now have, let's say, a word anyone, and now that word anyone is in this training data set. Then I do have an integer that tracks how many 6-letter words there are. So I'm just going to say that the 6-letter words, we're going to increment it by 1 because we found a word that was of length 6. So now we have the training data set, or now we're actually going through the file and just getting every 6-letter line, and we're appending it to the training data set. Once we're done doing all of this, we actually want to make the target data set, or the label, essentially the answers. As I've noted before, the target data set, we're going to be using 0 to represent English and 1 to represent German. The thing is that the index, or the place in which a word appears, corresponds to where a label appears. So that means that this first word has an answer of 0. This second word has the answer on the second place in the target array, which is 0. And let's say the last word, or the 6th word, has its answer in the 6th place of the target array, which is 1. We want to also essentially do that. And because we have all of the 6-letter word, or the count of the 6-letter words, we can go ahead and say that essentially the target for this class, or language, which we'll just call as class target, is equals to an empty list. And then for whatever in range of 6-letter words, let's append 0 to this class target. That way, for every 6-letter word that we found, we're going to append 0 to this array. I know this is not the most efficient way to do this, but it's a way that makes sense for new programmers. Lastly, if you remember what array concatenation is, when you add two arrays together, or when you add two lists together, it merely appends one list to the other one. So if we say target plus equals class target, whatever we built in class target will just get added to target starting from the end. So great, we were able to get all the 6-letter words, change them to their numerical representation, and then also append the appropriate label, which is 0 for English, to a class target, and then put that in our target array. Now, we essentially just have to do this for the German file, which is easy enough to do. Else, we can do else. You can also do if file equals German. And we'll just essentially do the same thing again. The only difference with this, right, we don't even need to change what ordered line representation we need. We just need to change what the class target is, which is 1, because we're trying to represent all of these words within the German text file, not anymore English text, as 1. When we do that, we can go ahead and check the arrays that were being built. So let's say, let's print training, and let's print the first 2 samples, as well as the target's first 2 samples. So as you can see here, we have 2 words in the training array, and both of the labels for these words are English, which makes sense because we did English first. When it does for file and files, it obviously reads the English file first. Let's go ahead and do the last 2 words. Oops, that's the last 3. When we do the last 2 words, it makes sense that the words are, well, the words are still 6 characters, but they're represented with 1 because we did German last. And so as you can see here, this also makes sense. So now we can go ahead and just create a very simple classifier. When you already have your training and your target data, all you essentially need to do is define a variable to hold the model. So for us, we can say multi-layer perceptual neural network equals MLP classifier. Remember that we represented that earlier here. We're importing that here. And then we can essentially call the MLP the variable's fit function, or the classifier's fit function, which is essentially another word for saying train the model that you have. So we can say that we're going to fit this training data with the target data we have. So fit these word representations to these labels. And when we do that, we essentially wait for it to train. I'm going to run it and see how long it takes. If it doesn't take too long, then that would be great. So now we have an MLP classifier. So that didn't take too long. Once you actually fit this neural network model, you can go ahead and actually test it. using mlp_nn.predict. Now, let's go ahead and say I want to predict an English word, and my English word is hello, just with a W at the end. We can go ahead and change this to the numerical representation. So in a simpler way of doing it, you could say ordered English equals the empty list, and for letter in English word, let's append to this created list the ord of the letter, or the ordinal value of this letter. And let's predict the ordered English word. As you can see, it still has to go through training again, but you can see that, interestingly enough, we have an array that contains 0, which means that the neural network thought that the word was English. We can try this with a German word. So German word equals, and we'll have a German word right here. I don't know how to say that. And then we can essentially change this in the same way, or do the same thing for this word. We can add it to our list. So we can say ordered German. It'll have to go through its training again. And as you can see now, it says hello was English, or it predicted hello as English, and it predicted German as 1. So this is a pretty good idea of like essentially going from start to finish, how to sift your data in means that makes sense to a neural network. And it contained a lot of things such as, for at least this example, nested for loops, if statements, and being able to add and append to arrays the numerical representation of each word. And then essentially to the target, appending the answers for each word to the target array, so that when you train this NLP classifier, it can actually determine the differences between English-like words and German-like words. Once you train them, you can essentially train it on words that it hasn't seen before, and then you can go ahead and predict per each word. So this is obviously open for questions, but what I'd like to show is how inefficient this entire thing is. And for any programmer who's looking at this code is atrocious looking. And it's because I wanted to create it in a way that would make sense for most people without doing too much of, Python-y syntax. But if I wanted to create this in pure Python, what's great about Python is that it's a scripting language that can be incredibly concise if you know enough about Python in the first place. So let's create a very concise version of the code from sklearn.neural network, import MLP classifier. And we have a question, is Unicode? What do you mean by is Unicode?
Yeah, this question is the because of the German character, right? It's not ASCII, right? Like the U, the U. Yeah, the German word. There's like your example. FL, like the UCHE.
It may be a Unicode representation of this, but as far as I know, ordinal values that are returned, they're ASCII, right?
Mm-hmm.
So I don't think it's Unicode.
I see. So, but okay.
So continuing from this, we're going to do the same thing in this concise version. And the reason why I want to show this concise version is to walk you through, I guess, the thought process of like creating this in Python. So we'll still have our training and target arrays. And no, I'm still not going to be using NumPy because for this example, it's not useful. I can say for IDX and file and enumerate. And I'm just going to say my English.txt and my German.txt. Let me just put pass here. What's nice about doing something like this is that you're taking what enumerate returns is both the value or the object represented during the current step of the for loop, as well as the index of where that object resides in. So file, for the first pass of the for loop, file will be English and IDX would be 0. And then on the second pass of the for loop, file would be German and IDX would be 1. For the more astute amongst you, you would notice that IDX would be very, very helpful for representing the classes, the different classes that we have. Because English would already be 0, German would already be 1, and you can add more text files in here, or you could do something like glob.glob start.text. And when you delete this, then you're going through every single file that has a text, and it's now length invariant, or it's invariant to actually hard coding your file names. But we have more than this text file, I believe, in this folder, so I'm not going to be doing that. Then what you can do is just do lines equals open the actual file and then read the lines. And then you can say sample is equals to, now remember that this essentially has to be a 2 double array list representation of the words. So each word is one array and then it's nested in another array. So we're essentially going to have double list generation. So in the inner list, we would say the order of each character for each character in line. But remember that our lines have new line characters, so we need to say for character in line dot replace the new line character with the empty character dot lower. So we're not only replacing it, we're also lowering the replaced list with all of the lowercase characters. But now we only did that for the inner list. Now we have to do that for every single word within the text file. So now we can say for line, in line, if the length of the line is equal to 7. So we're now doing double list generation in which on the first list, we're saying for each character within the line. And then this line is represented by every line within our lines, so file.readLines, if the length of line is equals to 7. The reason why we're saying 7 is because remember, in this line, the line is not replaced yet. So the line doesn't have the newer character replaced. And so you can always expect 6 length words to have a length plus 1 because it contains the new line character. So now that we created our sample for this particular file, whether it's English or German, then we can say that we'll concatenate to this training array the sample, which is this, and we'll concatenate to target IDX, which is the actual index of this file, for whatever in the range of the length of the sample. So essentially, the length of the sample, we're just going to keep appending 0 or 1, so 0, 1, depending if it's English or German, to the sample, and then we'll concatenate it to target. And then the rest is basically the same. LLP neural network equals MLP classifier, and then fit your training and target array together. So this looks fairly convoluted, but as you can see, this was done pretty quickly in very little amount or little lines of code. And if you're very used to like programming like this, or say, for example, F strings and putting things like list generation in your F strings, you can save a lot of lines of code and actually speed up the scripting time that you need to create some kind of simple project like this. I'm not sure if there was a question. Line or lines? So that would be interesting. Hopefully there was no typo here. Let's go print the length of training and target. That way let's not print that. Let's print the length of training and target. And target. That seems to be correct. Let's print training from till 3, let's say. Don't need to print target. 1, 2, 3, 6. So this seems to be working correctly. So I think maybe the confusion is that this line represents each individual line within lines. If the length of this line within lines is equals to 7. And so it can be very confusing when you shorten it, or if you do nested list comprehensions in Python. But yeah, this seems to be working a-okay, hopefully. And we can definitely test that if we go ahead and train it, or if we predict it. So we can do something really quickly in terms of like just doing the same kind of thing for the training data, except we're doing it for words that we're going to be testing. So our ordinal value of C for C in a word, for word in another list, which would be something like hello. And I can't obviously type this word, so let's copy and paste it. Hopefully that's correct. Oh, yeah, and it is correct. So as you can see, this very concise version of this long, inefficient, well, not inefficient necessarily, but it's the amount of lines it needed to take to do something simple, you know, is not ideal. But it did have the same output as this other version of the code. And so essentially, being used to Python can really speed up, like what I've said before, things that you need to be doing. It's the reason why Python is my preferred language for any kind of scripting task, even when it comes to things like web-based or websites or website backends. I tend not to use PHP. I tend to use Python because a lot of things are simplified if you're adept enough at it. So that's the end of that. I'll be happy to take any questions, whether there are questions about the first type of code or this more concise, very Pythonic type of code. Let me know.
So, from performance point of view, is both codes run in the same time, or can you time the first model and time the second model to see?
I can. There was a better way of doing that. Oh, it's like through time it, but I forget how to do time it. So I guess what I'll do is something like Python time. So
Yeah, that's fine. I can do it, and we'll check it out. Yes.
Yeah, Dex, I have a question. So in this case, the number of the, I think that is the only thing that when you talk about the neural network, the number of the hidden layers. So it's so it is determined by default value, or just the.
I'm sorry. So
Yeah, like the architecture of the like the MLP neural network, right? So we don't talk about it. Is it was determined by default value, or we only know that the input like it's six input. The output is like it's okay. It's binary, but we have not talked about any architecture like the the hidden layers, number of the.
oh
hidden
yeah,
layers.
so the MLP classifier in here, you can actually denote the actual hyperparameters that you want to put in. So for example, in here, you can put things such as the amount of hidden layers or nodes within the thing. So I can say something like hidden layer sizes equals a one element tuple. You can put optimizers such as solver equals atom. You can put things such as your activation function. You can put the, the actual random state, et cetera, of this neural network. Thing is, though, is that I didn't want to talk about that as that was outside of the scope of a Python bootcamp. I just wanted to show how you can fit essentially numerical representations of words into a neural network. Now, if you are interested with things such as what Dr. Liang was saying, I heavily recommend you guys to look at something like assignment number 2. Ooh, it looks very ugly in Jupyter Notebook. The second homework we give to students, and trust me, the assignments aren't necessarily tough, but here I give you a diagram of the importance of preprocessing and things such as activation functions and the actual representation of these activation functions when input data is being sifted through them. I even have my legs to use as an analogy for activation functions, so there's that. And then what I talk about is essentially a lot of the same things in terms of, processing your data and then creating a neural network model and how to do that yourself using Keras instead of sklearn. And I've written a lot of text to walk you through this type of stuff. You can do that here. However, I don't recommend. And that's because sklearn prints on your CPU and it's very slow. So I'd recommend you do something like Keras instead. But if you're hell-bent into using sklearn or you think it's not that big of a deal, then sklearn has a ton of models included that are predefined that you can tweak very easily through a singular line of code. That being said, I'm gonna go ahead. Control Y, import 9. Okay, so I doubt it's going to be good for this. So if we go ahead and we can go ahead and just define this as and we're just going to do that, and we're not going to train it. We're just going to continue to do this. I'll just essentially just showing you guys how fast it may or may not be. 2 and oh, boy, did I, oops. Okay. Should non-destructive copy that. And do that. That looks like the correct format. This looks like the correct format. Yeah, I'm doing this like incredibly ugly, but hopefully this results into something. 2.6 and 0.16. Okay, so it's like almost 2 times faster doing list comprehensions, which I kind of expected because list comprehensions are usually the preferred way of doing things such as this. I forget the properties of actual generators. They're certainly faster than C compiled things because there's overhead with calling a C library through Python. And if you're going to do that repeatedly through a for loop, there's a lot of overhead incurred, which is why for C compiled libraries, you want to do things such as broadcasting. But for, I guess, pure Python implementations, doing list generation is faster. Also, this type of code is very inefficient, just because it was done in ways that would make sense for a new programmer, but not so much for definitely not as intuitive as doing, or definitely more intuitive than doing something like a Pythonic version of that code. So anyway, that was a cool experiment. Any other questions? All right, cool. So this information is still in the Python Bootcamp folder. So if you go ahead into ML and assignment 1, there's a for scratch homework 1 that I did when I first taught this homework 1 from scratch thing through iCompile. And so for people like you who are learning Python or are not familiar with coding, I've written a lot of comments, goes through each and every line, and the intuition behind doing something like this.
Sorry about that, Dex. Did you share this to the GitHub, to the address to the
yeah, so it's available in GitHub. You go into Python Bootcamp, which is the link that we showed to you. You go into ML, you go into assignment 1, and you can see forum scratch homework 1. You click that, and once it loads, this table of contents is clickable if you open it in Jupyter Notebook, I believe. So you can go ahead and click this. It goes straight to long version with comments, long version without comments. And that link doesn't work, but the actual concise version is down there. So yeah, all found within the GitHub. So, and like I said before, things such as convolutional neural networks, there are tutorials and instructions that we give to other people. We even have things here such as batch normalization can be found within that same folder. Some of the homeworks aren't given. You'd have to come to our class in order to get those files. Or well, I guess you could ask a person who already took it to show you the link, but I don't recommend it. That being said, there are some things in here that I'd like to talk about that I haven't talked about, including, so I talk about normalization. I don't talk about things such as translational, invariance as part of convolutional networks and their pooling layers, but something you can learn about in the Intro to ML class speech. So yeah. Anyway, this is a Python bootcamp, so I'm going to stop talking about neural networks, even though that's the thing I'm most interested in. Dr. Liang, is there anything else you'd like to say or talk about?
I got some email from some audience. They still have not got the address of this GitHub. So can
so I believe last time we put it in chat.
Yes, but there's some new audience. Can you just copy and paste?
So it's this link.
Yeah, can you copy and paste to the, okay.
Yeah, so it's already in chat. It's under IconBio UTC's group because this Python file was originally created for that. Hey, look, there's Caleb. This was originally created for IconBio, so it's under this repository group under GitHub.
Mm-hmm. Yeah, I got a couple of email asking about this is the, yeah, okay.
All right. Anything else you would like to say, Dr. Liang, before we end?
No. Any questions? Now it's question and answer now. Okay. Similar people, okay. Anybody have questions?
I mean, very straightforward session today, so I don't expect there to be, unless of course there was something I glossed over, feel free to let me know, but pretty straightforward, so cool.
Okay.
All right, so thank you everybody. Dr. Liang, would you like to formally end this session?
Okay, yes. I'm going, thank you. I think this is the last workshop, I think the meeting for this year for the HDR program. And thank you for your great patience and thank you for joining. So next year, we will do the same thing. Maybe I think that we are going to have more, I'm sure that we're going to have more information just to share with you guys. Okay, please spend some time. I'm going to upload this in a talk on the YouTube. Please spend time on submit your reviewer, okay? So that the NSF people they will know about it. Okay. So also, if you want to know more about the neural network, I think Dex, he's expert in this area. He knows a lot of technical detail. So you are welcome to contact him. Dex, do you mind write down your email on the chat room?
Sure. That's my email. If you'd like to ask me anything about neural networks or previous work that I've done before, feel free to let me know. I'm always very excited to talk about neural networks. So yeah.
I know it's almost the mission impossible to cover everything about the neural network in just in 1 or 2 hours. It's almost impossible. So the best way to learn that is just spend time on it, get some code from the GitHub and try it by yourself, and that's the best way to learn that. Yeah. So
I feel so. Generally speaking, the best way to learn neural networks, especially if you want to learn it in a very small amount of time, I really highly suggest people to work on things such as Kaggle competitions. So the reason why it's so helpful is because actually a lot of times the solutions that are posted through Kaggle competitions or you entering a Kaggle competition and trying out your work can be very insightful in the things not only that you need to be doing for a certain amount of data, but also the kind of solutions that people who are much more adept at neural networks, what they're employing in their neural network. Then you learn things such as cosine annealing or gradient accumulation, or you do stat convolution for ensembling, like a lot of these different, techniques that may not be necessarily covered even in well-established neural network tutorials. So I highly recommend that. Usually what's exciting about entering Kaggle competitions is you'll see very prominent players within these competitions. I remember in last year's Herbarium 2019 challenge that was put together. So I'm a botanist, or I want to be a computational biologist. That's what I want to do for my PhD once I get out of my undergrad. And what I essentially am focusing on is things like botany. And in last year's Kaggle competition that was hosted by the New York Botanical Garden in collaboration with Google and Cornell, is that many prominent players, such as Facebook AI, actually entered that competition. And their solutions were very insightful for the people who were entering and posting solutions to that competition. And that competition was to create a neural network to tackle fine-grained visual categorization, which is essentially what botanical image analysis has become. So there's that. I feel so enter Kaggle competitions. If you're confident enough in your programming and you really want to get into neural networks, that's definitely the best place to do it and to learn really quickly about it. So, yeah.
Okay, I think let's stop here. So everything good. I will see you guys next year. Okay. Thanks everybody.
All right. Thank you, everyone. See ya.
Okay.